Welcome to class. Today we're going to take a look at solving polynomial equations with complex root. Okay, so given equation, cube root, and so on, polynomial equations, we're going to solve them even if they contain complex root. Okay, so we usually used to leave them when they contain complex root, but in this case, we're going to be solving them and giving out the solutions in complex form. Okay, so what we're going to learn is the first thing is we're going to solve quadratic equation that yield in complex roots. Okay, so this is it. You just have to solve a quadratic equation and it will give you a complex root. Then the other thing is we are going to apply the conjugate root theorem. Okay, so there's a theorem for a conjugate root. Okay, it is for polynomials with real coefficients. Okay, so given a polynomial with real coefficients, we're going to apply the conjugate root to get our answers. Okay, then the other thing is we're going to use factor theorem and synthetic division to solve high order polynomial equations. Okay, so after that, we're going to see how can we solve polynomials which contain these complex roots. Okay, so let's get into it. This is our question, quadratic equations with complex root. Okay, so we're going to solve this one, which says that x squared plus 4x plus plus 5 is equals to 0. Okay, so before we solve, let's take a look at the quadratic form. Okay, the quadratic form is like this: ax squared plus bx plus c is equals to 0. Okay, so to see that this is going to give us a complex root, what we do is we just take b squared minus 4ac. Okay, so if this one is less than 0, okay, this means that it's going to give us a complex root. Okay, if you see it negative, this means that it's going to give us a complex root. Okay, so let's see how do we find those roots. Okay, so in this case we're going to be using a quadratic formula. Okay, so make sure you remember it. The quadratic formula says that x is equals to minus b plus or minus root b squared minus 4ac. Okay, so that's it. Okay, then over 2a. Okay, so this is the quadratic formula we are going to be using in this lecture. Okay, so in this case, we are just going to substitute this. Okay, so here you can see that a is the coefficient of x squared. Okay, so in this case, you are going to see that a is equals to 1. Then here b is the coefficient of x. In this case, b is equals to 4. Then c is the constant. Okay, so in this case, you're going to see that c is equals to 5. Okay, so now our duty is just to substitute in this. Okay, so this means that x is going to become minus b, which means that it's going to become minus 4 plus or minus root b squared. This means that it's 4 squared minus 4 multiplied by a. Our a is 1. Okay, then our c is 5. Okay, so this means that we're going to get this. Okay, then we are going to say over 2. Our a is 1. Okay, now after that we are going to solve this. Okay, solving this, we're going to see that we're going to get x. Let me start from the top here. We're going to get that x is equals to minus 4 plus or minus root 4 squared is 16 minus 4 times 1 times 5 is going to give us 20 over 2. Okay, 2 times 1, we're going to get 2. Okay, so now this means that our x value is going to become minus 4 plus or minus root of minus 4 over 2. Okay, so I remember I told you that whenever you see a root of a negative number like this, minus 4. Okay, so this means that we're going to say a root of this number positive times I. Okay, so this is the meaning of I. I just means root minus 1. Okay, so this means that we're going to get this one. Okay, so root of 4 in this case is a 2. Okay, so this means that from this we're going to get our answer as 2i. Okay, so this means that our answer x is equals to minus 4 plus or minus 2i over 2. Okay, so dividing by 2, we're going to get our answer as minus 2 plus or minus I. Okay, so this means that our answer of this equation is x is equals to minus 2 plus I, or it's going to become minus 2 minus I. Okay, so these are the solutions of this. Okay, so this is the way you find the complex roots. Okay, so you just have to use this formula. We already know it, and after that we are just going to take this negative root and say that this is our root. If it's root minus 4, we're going to take root plus 4 multiplied by I. Okay, so this is it. This is how we solve. Now let's go in and see the next concept. Now let's look at conjugate root theorem. Okay, so I'm going to be using this question to explain to you this theorem. Okay, so this question says that given that f of x is equals to x to the power 3 minus 3x squared plus 4x minus 12, and x is equals to 2i is a root. Okay, so this is said to be a root of this one. Then find the other two roots. Okay, so you can see that this equation gives us two roots. So we want to see the other two roots and we have this one. Okay, so the roots of this equation, the equation will be f of x is equals to 0. Okay, so I remember we used to factorize this, but this in this case we have these roots. Okay, so we have to use the factorization, but in this case we're going to include complex numbers. Okay, so the conjugate root theorem says that when you are given a complex number as a root, this means that its conjugate is also a root. Okay, so let me write it down here. Okay, so this is it. So this means that here we have x is equals to 2i as the first root. This means that also x is equals to minus 2i is also a root of this. Okay, so now we can see that we have two roots of this equation. What's left is to find the third root. Okay, so what we do here, we combine these roots to form a one quadratic equation. How do we do that? If we are given that x is equals to 2i is a root, this means that x minus 2i is a factor. Okay, so this means that this one is a factor of this, and this means that here x plus 2i is also a factor. Okay, is also a factor of this. Okay, so now to find we want to combine this so that we divide and find the remaining factor. Okay, so what we do here, we're just going to say x minus 2i multiplied by x plus 2i. Okay, so in this case, we're going to get here x squared, then here we're going to get minus 2xi, then here we're going to get plus 2xi, then here we're going to get minus 4i squared. Okay, so if we work out this here, we're going to get here we have x squared, and here minus 2xi and plus 2xi gives us 0. So we're going to be left with minus 4, and I squared is minus 1. Okay, so this means that we're going to be left with the function x squared plus 4. Okay, so this means that this one is a factor of this function. Okay, so now our next duty is to divide. Okay, so how do we divide? We just do long division. We just x squared plus 4. Then you put this function x to the power 3 minus 3x squared plus 4x minus 12. Okay, so this is it. Now we're going to get x here. Then we multiply x, this x squared into x to the power 3, we're going to get x here. So x multiplied by this, we're going to get x to the power 3. Then here we're going to get plus 4x. Okay, so after that, we're going to subtract these two. Subtracting these two, we're going to get here we're going to get 0, and here we're going to get minus 3x squared minus 3x squared. Then here we're going to say plus 4x minus 4x, you're going to get 0. Then here we're going to get minus 12. Then we're going to say x squared into minus 3x squared, we're going to get minus 3 here. Then now we're going to multiply again here, we're going to get minus 3x squared and minus 12. Okay, so if you get 0 here, this means that you did everything correct now. Okay, so this means that we have these two factors, x squared plus 4, and we have x minus 3, okay, as the other factor. Okay, so this means that here, if you say f of x, this one is equals to 0, this one we already found its roots are these ones. Okay, so the left, what's left is this one. Okay, so this means that we're going to say x minus 3 is equals to 0. Okay, so this means that x is equals to 3. Okay, so now we can see that we have our three roots. The first root is x is equals to 2i, x is equals to minus 2i, and x is equals to 3. Okay, so these are our solutions of this. Okay, so the conjugate root theorem just says that if a complex number is a root of an equation, its conjugate should be a root again. Okay, so with that, we can combine those two and form a quadratic equation, then divide to find the remaining factor. Okay, you can do this on the on polynomials with to the power 4 and power 5. Okay, there are other laws we have to apply. Okay, so make sure you subscribe so that when you do those laws, you don't miss them. When dealing with polynomials, this is the most important theorem you have to remember. Okay, so it is says that given that x minus a is a factor Okay, given that x minus a is a factor of f of x, that means that f of a, okay, is equals to 0. Okay, this is the meaning of factor theorem. Given that x minus a is a factor of f of x, this means that f of a is equals to 0. Okay, so the first thing we did, we changed this sign and substituted every x value in f of x with a. We are going to get 0. Okay, so this theorem, we use it a lot find solutions. We're going to see an example we're going to do here. Okay, so this is what we call the factor theorem. Okay, so given this as a factor, this means that if you substitute this value, change the sign to the function, you're going to get 0. Okay, so we usually use this equation to solve the equation, and we use synthetic division. Okay, so now let's take a look at what is synthetic division, and I will explain these two together with the example. Now let's talk about synthetic division, and I'm going to talk it to first use the factor theorem we talked about. Then next we're going to use synthetic division. Okay, so this is saying that given that f of x is equals to x to the power 3 minus 6x squared plus 11x minus 6. Okay, solve f of x is equals to 0. Okay, so what we're going to do, the first thing is we're going to say a. Okay, we want to find a factor x minus a. We want to find a factor x minus a. Okay, so we're going to test our a. Our a is equals to, so we're going to test from 1, 2, 3, 4. Okay, until we find which will give us 0. Okay, until we found that f of a is equals to 0. Okay, so if f of a is equals to 0, this means that this one becomes a factor. Okay, so let's try with 1. Okay, so we're going to find f of 1 first. Okay, f of 1, this means that we are going to substitute 1 where there is x. Okay, so this means that we are going to get 1 to the power 3 minus 6, 1 squared plus 11 times 1 minus 6. Okay, in this case, we're going to get 1 minus 6 plus 11 minus 6. Okay, if we solve this, we're going to get 0. Okay, so this means that x minus 1 is a factor of this. Okay, so this means that we can simply factorize this function as easily. Okay, so now we know that x minus 1 is a factor of this. Okay, so we have used factor theorem. Okay, so this was factor theorem. Okay, now let's take a look at the synthetic division. Okay, so synthetic division is that if we know that this is a factor, okay, we're going to take this a value and change it to become 1. Okay, so the first we're going to take the a value, in this case is 1. Okay, so to find the other quadratic equation here, we're going to take 1 and put it here. Then we're going to create a table like this. Then you're going to write the coefficient. In this case, it's 1, and the next one is minus 6, and the next one is 11, and the next one is minus 6. Okay, so what we do is, the first thing we do is we take this one. Okay, we leave a row here. Then we take this one and put it here. Okay, then we say 1 multiplied by 1, we're going to get 1. Okay, so we put 1 here. Okay, this multiplied by this, then we get this. Okay, after that we just add this one becomes minus 5. Okay, then we say minus 5 multiplied by 1, we're going to get minus 5, then we're going to put minus 5 here. Okay, then we add here, we're going to get 6. Then after that we're going to say 6 multiplied by 1, we're going to get 6 multiplied by 1, we're going to get 6. Okay, so this means that we're going to put 6 here. Okay, here 6 minus 6 is going to 0. Okay, so if you get 0 here, this one is a factor. Okay, this means that is correct. Okay, so our answer becomes, this means that this function is equal to this one. Okay, so this means that f of x is equals to x minus 1 and x squared minus 5x plus 6. Okay, so this means that we have successfully factorized this. Okay, but we are still left to factorize this. Okay, so factorizing this, we're going to say x minus 1. Okay, so factorizing this is very easy. I remember I've taught many things about this. Okay, so factorizing this, we're just going to find the numbers we add to get minus 5 and the numbers we multiply, we can say product, to get 6. Okay, in this case, these numbers are minus 3 and minus 2. Okay, so what we're going to do is we're going to say x minus 3 and x minus 2. Okay, now we got our answer. Okay, so this is f of x. Okay, so now f of x is equals to 0 is now easy. Okay, we're just going to say x, in this case we're going to say x is equals to 1, x is equals to 3, and x is equals to 2. Okay, I believe that if you get here, you can simply solve this. Okay, so this is it on synthetic division, and that was that on conjugate solutions and factor theorem and everything we learned. Okay, so this is this. Okay, make sure you grab this concept. It is very, very important. You can save time with it. Okay, and make sure you grab all these concepts because they are most important. Okay, so now see you next time in the next video.